Hello. In this video, I will show you how to generate and use Amazon Inspector SBOM exports. First, let's understand what is a SBOM and why should you care. SBOM stands for Software Bill of Materials. It contains machine-readable nested inventory of all open source and third-party software components of your codebase and its supply chain. SBOMs can be used to understand the software you consume and vulnerabilities associated with any dependencies. Think about the food you eat. Assume you're allergic to strawberries, so you need to know the ingredients of the food to understand if there are any strawberries used in the preparation. If you know the producer is strawberry, then it's obvious you should not be eating it. However, if you're eating chocolate-coated fruit, you need to know the fruit inside the chocolate is a strawberry, so you do not consume it. Next, say you're eating an ice cream sundae. You would want to check all the ingredients of the sundae, including all the sub-ingredients. The sundae could have chocolate brownie with vanilla M&M ice cream that has mixed M&M flavors, including strawberry M&M. In order to truly understand if strawberries were used anywhere in the supply chain, you may need to know the details about all ingredients, how they were prepared, and even where they are sourced from to see if there could be contaminants. An SBOM gives you such details about the software and hardware inventory, plot direct or transitive dependency graphs. It can also help you identify known vulnerabilities, verify integrity of packages, origin of software components, and also support audit use cases. Amazon Inspector provides SBOMs for individual or groups of resources monitored by Inspector in your environment. These can be exported into an Amazon S3 bucket. Inspector supports exporting SBOMs in CycloneDX and SPDX formats. Both these formats are leading industry standards for SBOMs. SBOMs exported from Inspector can help you gain visibility into your software supply chain. You can garner information such as the most commonly used packages and associated vulnerabilities across your organization. Once exported to S3, you can use Athena or QuickSight to run queries on these reports. Now let's look at how you can generate an SBOM from Inspector. If you want to export the SBOM from multiple accounts in your AWS organization, you will need to generate the SBOM from your Inspector Delegated Administrator account. In this scenario, I am logged into my Delegated Admin account. You will first need to configure the S3 bucket and the AWS KMS key that Inspector is allowed to use to export. Configurations and permissions needed for the S3 bucket and KMS can be found in the Inspector documentation. If you have previously configured an S3 bucket and AWS KMS key for findings export, you can use the same bucket and key for SBOM export as well. Let's say you want to identify top vulnerabilities affecting your workloads, and you want to search through the primary software components as well as the dependencies. You can use the SBOM for this use case. First, you will need to generate the SBOM. In the Inspector console, choose Export SBOMs. Here you can either export reports from all active resources or a subset of resources using filters. Next, select the format, SPDX or CycloneDX. Choose this S3 bucket destination for export. Then select the KMS key and then click Export. You will see the status bar indicating the export is in progress. Once complete, the status will change to green. Let's go look at our export in S3. Inspector will create an SBOM file for each active resource that Inspector is monitoring. Since we do not use any filter, Inspector will partition the SBOMs by account ID and resource type. As you can see here, I have SBOMs here for EC2 instances, container images, and Lambda functions. And finally, you can see there's a SBOM for each resource ID. Let's open an SBOM. I will paste the contents in a JSON prettifier to view the report with indentation. There you go. Now you can see the contents of the SBOM. Since this is CycloneDX format, you can see the version number, metadata such as the timestamp when the SBOM was generated, operating system information, properties applicable to the organization using the SBOM, which in case of AWS would be account ID, resource type, ARN, etc. The components include the inventory, the first-party and the third-party software packages and dependencies in those resources. You can also see the package URL or PURL, which includes the name of the package, version number, subpath, etc. As you can see, the list is long since this is an EC2 instance. It includes the OS packages as well as the programming language packages. Now, if you scroll all the way towards the bottom, you can see the vulnerabilities associated with software components listed here as well. Let's take a quick look at the XPDX version. I already have a SBOM exported in SPTX. As you can see, this is a different format which has similar information as compared to CycloneDX. Now that the SBOM is generated, we will use Athena to identify the top vulnerabilities in the workload. In this demo, I've already set up a glue crawler for schema generation and then created a table from it. To learn more about the glue crawler setup, visit this link. In this query, I'm listing the top 10 items in the table. You can see the contents are similar to the raw SBOM we saw a few minutes ago. For the rest of the demo, I will be querying the SBOMs in the CycloneDX format. You can use similar queries for SPDX as well. Now let's query the report to identify the top 10 vulnerabilities for resources in the SBOM. You can then use these CVE IDs to list the individual components affected by the CVEs. Let's look at another query that can be used to identify top operating systems along with resource types and their counts. Say you want to identify the counts of packages that are used in the workloads. This next query can help you with it. This information can then be used for risk assessments and remediation prioritization. Finally, let's say you have a package that has a critical zero-day vulnerability and you need to know if the package is used in the workload as a primary package or a dependency. You can use this query to identify the existence of this package in your application. In this example, I'm searching for ncurses package. The results show the account number, the resource type, and the count for this package. Once you identify where these packages exist, you can begin your vulnerability remediation efforts. You can reproduce the SBOMs in your accounts by following Inspector's SBOM export documentation. You can use the console or generate the SBOM programmatically using the Create SBOM Export API operation. In this video, we learned about SBOM, its use cases, and how to generate it using Amazon Inspector for supported resources, and then querying it using Athena. Thanks for watching.